Hello and welcome back to my channel. Today we're going to talk about insecure MQTT traffic. So what the heck is MQTT? Now, before we actually dive into the lab, I want to explain to you exactly what the MQTT protocol is all about. So we are talking about a protocol used to communicate with IoT devices. That could be things like, sensors or your smart light bulb from Philips or some sort of thing you have in your apartment that is connected to the internet. So it's an IoT device, Internet of Things, right? So that could basically be anything. So imagine that you have a light bulb and you have that connected in your ceiling, and then you install an app on your smart device. And then you communicate with that smart device, you communicate with that light bulb through the smart device, okay? And then you send that light bulb a message to turn on. Well, basically, you're not sending the light bulb a message, you're sending it to an MQTT broker, which is actually a server somewhere. And depending on, how that traffic is created, with or without encryption, that is, we can actually sniff that if we are on the particular network where the traffic is being sent. Okay, so that is actually pretty serious. So the actual example that I just talked about before is here in text. And that could be, you have some sort of status message, like saying status on. As you can see, that is a like an object setting something on and off. It could be anything like your living room. It could be a coffee machine. It could be like a light bulb, a whatever you have IoT device. And IoT devices are also like normal smartphones, basically also a computer. But usually when we talk about these lightweight products that need to communicate somewhere smart, through an app, you usually use the MQTT protocol, and you use the broker as a middleman server. And then you use a smartphone app to subscribe the publisher setup, and that is actually design pattern. And nothing wrong with that if it's done properly, but a lot of it is not. So why does all this matter for security? And we talked about this before. Unencrypted traffic, sent on the network is basically a really bad idea, even though it is internal, even worse if it's something that goes on the internet, because many of these MQTT brokers actually also do not use encryption, which basically means that we can probably even, communicate with the broker and maybe even get to the actual device and IP addresses and maybe try and infect them. And that is one of the ways that the Mirai botnet probably got that big back in the days. So we're going to look at something called Wireshark today, and it's a program we can sniff traffic with, and it's going to be a pretty quick task. And we will see Wireshark boot up a lot of traffic, and you can use different kind of filters. I have them here on my slideshow. So basically just go ahead and type those. MQTT for the protocol, TCP if you want to see all TCP traffic, or TCP port equal 811A3. That is the default port for the protocol that is no encrypted. All right, so let's go ahead and go right to the lab. So we're back again here in a lab environment on Campfire Security. They have set up a lab for us where we can test the MQTT protocol and actually try and sniff the protocol using Wireshark. Let's go ahead and open the lab. Already started the lab. I'm going to allow copy pasting back and forth. And there's a small icon here. It's a blue one. It's called Wireshark. Go ahead and click that. Now, while this is just, loading up, you should definitely go ahead and read the text I have here on my screen. Basically, it talks about like what can you find and what are normal security misconfigurations, because this is also a part of the OWASP top 10, which is about, web configuration stuff and web vulnerability stuff. When I say configuration for web, the OWASP is the Open Web Application Security Project, and the top 10 contains the 10 most discussed vulnerabilities, not meaning that there are not 11 or 12 or 13, it's just the 10 most, right? So go and read the text, and we're going to go ahead and find the flag. And there's a text here saying like, okay, so go ahead and check out for some MQTT traffic. So I'm gonna, just make this a big bigger and go to ETH0 and start and sniff the traffic that is on this server right now. And definitely we can see that we got a lot of traffic already. One of the packages here is actually called MQTT, and well, it's maybe a bit easy for us to see like info flag, blah, blah, blah. But when we can click that, I think we should just press stop now. And we can try some of the filters just for the sake of it. So if you decide, for example, TCP, we will see only TCP traffic. And since the MQTT is also using TCP, since we can see that, click the package, and you can see down here below in the package description that there is a transmission control protocol containing the port, the source port, and destination port. And you can see destination port is 1883, which is also one of the ports we can go ahead and filter for TCP port equal, and then 1883. And then we can also see all the traffic that is directed towards that particular port. So we have a few MQTT traffic packages, and some of them looks very interesting. There's a response, and we can see that the response down here below doesn't really give that much indication of, any hidden messages, just some header flags and some expert info, whatever you want to call that. But I'm gonna take the request again, and that's also the same, not that interesting, but there's one up here, it's called the public message. And we also have two of them. I think they're almost the same. You can see the length is sort that to 112. So now I want to say this one more time. This is a lab exercise. And the lab exercise is, well, there's a server sending traffic to us, and that traffic is something we can capture. So this is actually emulating the real world of how we see traffic in Wireshark. So if you want to learn more about Wireshark, I do have a lot of videos on my channel about Wireshark, and I'm gonna, link them in description as well in this video, so you can go ahead and check it out if you want to learn more about Wireshark. But I truly believe that I'm not gonna be too technical in this video, but more explaining what the things it's all about. So go ahead and click that MQTT protocol. You can see it says protocol, the package right there, and we can scroll down a bit and see we have the message. And when I click the message down here below, it's not encrypted, but it's probably encoded in some way with ASCII code or something like that, a hexadecimal code, sorry. And you see that the flag is actually right here, says fire HRRV9, blah, blah, blah. So what we could basically do is go down here and try and copy paste this, like say, as ASCII text, and see if that is actually something that's gonna work for us. And then we're gonna get a lot of the things, and we just remove some of it and basically submit the flag, and then we're done. So the problem here is that we can read the packages, and because the data is sent like in hexadecimal, we also have a hexadecimal view over here on the right side, and then we can basically just scroll over or just tab here on the left side and see which part of the package is actually containing these things here. Now the MSE length is not something that you see in the package, but you only see the actual number 2444, or the message is not there directly, but it's only the package. So this is an ordered, protocol, meaning that someone made it and said like this is how long it can be, or always the first 4 bytes, and so on, which is also why that whenever you have a port number, for example, this one here, 53,056, you can only get up to 65,535 different ports. And why is that? That's because you have 2 bytes of data, and that is the biggest number that 2 bytes can create. But that is one of the examples. That is why we always have an ordered amount of bytes you can chunk out and say this is the source port, this is the destination port. All right, so I hope that kind of made a bit of explanation to it, but I'm also going to highly suggest you go ahead and watch some of my videos about Wireshark on my channel. Again, I have a link to them in the description below, direct links. And, this is one of the things that happen whenever you have these devices. So if you have, IoT devices in your company, go ahead and put yourself in that network and start Wireshark. It is this easy. Just go ahead and type, MQTT, for example, and see what kind of packages you get. Also go ahead and check out all the other kind of traffic, also filter on TCP, see whatever traffic there is, also go ahead and try and filter on different kind of ports. For example, 1883, which is the port used for unencrypted traffic for the MQTT protocol in this particular case here. All right, so I hope that you learned something about this particular vulnerability, and also learned about that we need to do better and we need to pay more attention to what we put on our network. This is an actual lab exercise. You can also go ahead and do that. So if you want to try to do these labs that I do and learn more about network monitoring and the security configuration and stuff like that, go ahead and check out Campfire Security. I'll have a link to that in the description below with some discount code you can go ahead and use so you can get a more interesting price for a subscription that you could also go ahead and check out on the website. So anyways, I hope that you enjoyed the video, and if you have any questions, just directly below in the comments below. And also if you have any, things other than that, just go ahead and reach out. I'm going to get back to you. And also please consider subscribing to the channel, because it will greatly help me to grow, and it will support my channel by clicking subscribe and click the notification bell, like the video also, and it's gonna make the day even better. So have a really nice day and stay secure out there, and don't buy too many IoT devices.